Yeah. Yeah, that'll be fine. Just remind me. If I did not get a chance to look at your homework yesterday, make sure you show me today so I can get those grades put in as well. Okay. Solving linear equations. This is something that we've been doing for a long time. Okay. We're going to look at some different variations of some linear equations, and like when you started doing this back in Algebra 1, you would have started with like one step and then two step and then variables on both sides, and then you had multi-step with parentheses included. We're going to see all the different variations today. Some of them are going to be really quick and easy. Some of them are going to take a little bit more time to solve. The one thing that I will continue to tell you about equations is I like it because you can check every single answer, right? If I have an equation and I get an answer of x equals 2, I can take 2, I can plug it back in, and I can get an answer, okay, and see if it works. And if it doesn't work, then that tells me something's wrong. And so on like the test next week, then you have the opportunity to check your answer if you have an equation, okay? And we'll talk about that a little bit. I won't do it every single time, but that is an option, okay? So we're talking about things like, let's just start with a really easy one. 2x plus 3 equals 5, okay? This is a linear equation. No variables, no exponent, or we have one variable, no exponents, and we're going to solve. Good morning, guys. So we know from all of our years in solving equations, trying to get x by itself, we got to do the opposite operation, and whatever I do to one side, I got to do to the other. I divide by 2, and we get x equals 1. Okay? And what I was talking about just a second ago, thank you guys. We're going to take that, we can plug it back in, and we can just verify really quickly that it works. Do you have to show me the check? No, but that's just kind of for your own benefit of definitely seeing that it definitely works. 2 times 1 is 2, 2 plus 3 is 5. There it is, okay? And so we have, without a doubt, the answer, and it works. Sometimes it's easier to check than others. When we start getting equations that have multiple variables in it, or they're a big long equation, some are going to be a little bit harder to check. Let's say my answer is a fraction, okay? Then that's going to be a little bit more difficult to check. So some will be really easy to check, some will be a little bit more difficult to check. Okay, I'm going to show you this method, and this will come in helpful later in the semester when we're doing more with our calculator. If I were to show you this equation, okay, we can definitely solve by hand. Okay, we're going to solve it by hand really quickly, and then I'm going to show you an alternate method that we can use to solve. Okay, so in this case, subtract 2x from both sides. And I kind of like to combine 2 steps into one if we can. And we get x equals 4. Okay. Not too difficult of an equation to solve. I can take 4, plug it back in. We had kind of a problem like this yesterday on the quiz, where if I take 4 and plug it in, 3 times 4 is 12, 12 minus 5 is 7. Over here, 4 times 2 is 8, 8 minus 1 is 7. Both sides equal 7. So as long as both sides equal each other, then we know we've got a correct variable. Okay, an alternative to this, and I just want to show you this because I think later in the semester we're going to do a lot of stuff in our calculator. And I want to show you how you could do this in your calculator pretty quickly as well. Not that was hard, but sometimes, let's say I get a fraction or a decimal, maybe I can have another way of doing this. We can put this into our calculator as 2 separate equations. And because they're both linear equations, we could put it in as 2 separate linear graphs, which we kind of talked about earlier in the chapter, right? And we could graph it. And when we look for the solution, what we're going to look for here is, where do those 2 lines cross? Okay, so let's put this in kind of quickly here. If you got your calculator, you can grab it real quick. Okay, This one's a little bit more involved. Still got variables, right? Still got an x. But now we got parentheses and we got all kinds of things going on. Okay? And there's a couple reasons why I throw you one like this is there's a lot of common mistakes that are made here. Okay, so if I look at this equation, what would be my first instinct on the first step that I would have to do? Distribute, right? When I see parentheses and when I see something directly in front of parentheses, I got to distribute. We got to distribute here and we have to distribute here. One of the common mistakes that's made here is I see people try to add or subtract these two together. Can't do that, right? We have to distribute the 3 before I can do any addition or subtraction. Okay, multiplication or parentheses comes before we do any addition and subtraction. So the left-hand side's pretty straightforward. Take 2 times both. So 10 minus 6x. Over here, when I distribute, and this is another thing that you kind of want to watch for or be careful of, not only are we going to distribute the 3, we're going to distribute the negative 3. So the 8 is just going to stay 8 minus 3x minus 6. Okay. So that's step 1. Just get rid of those parentheses. What about our second step, our next step? Combine like terms. Okay, if there's anything on either side to combine, we don't have anything over here to combine. This has an x, this one doesn't, you can combine it. Over here, we can combine the 8 and the 6. 3 has an x on it, so we can't combine it. So watch the signs that are directly in front of the numbers. 8 minus 6. How you write that is kind of up to you. 8 minus 6 is 2, so I'm just going to go ahead and put 2 minus 3x. I could also write negative 3x plus 2. Okay, so it's kind of up to you what makes more sense to write it. Either way would be fine. And then we're always trying to get x by itself, so we're trying to move x. A lot of times we like x being on the left, but it doesn't really matter, right? I can move x to the right, and probably here I would probably prefer to move the x's to the right because by adding 6x to the negative 3x, that would make my x's positive, okay? And it would get rid of some negatives. So that's probably the step I would do next. If you're one that really likes the x being on the left, and like tomorrow when we do inequalities, we're going to want that x on the left-hand side, so that's probably the way we'll do it tomorrow. But for today, when we have an equation, it really doesn't matter. And I'm going to subtract 2 then from the other side. So if I move x's to the right, everything else has got to go to the other side. So we got 8 over here. We got 3x over here. And that would be my answer. So yes, we do get fractions sometimes, right? And based off the quiz yesterday, I can tell some of us don't love fractions, like on those ones where we had to write an equation in slope-intercept form and we had some fractions. There was a lot of mistakes made dealing with the fractions and those problems. So make sure you know kind of how to go through and deal with fractions when you have them. Okay. Your calculator, in most cases, will help you with that too, if you need some help with that. Okay, I'm not going to kind of like that where we have one particular answer. Spend a ton of time going through all the different types of equations because I know we've seen a lot of those before. A couple of other things to kind of throw at you, and then we're going to do some story problems where we are given, it's kind of like the Fahrenheit and Celsius one yesterday on the quiz, where we're going to have an equation except this. The equation might be a little bit more involved or a different scenario. But before we get there, okay, it's a pretty straightforward equation here. And we could give you a really long one, and this could happen, but I'm just giving you one pretty straightforward here where we're trying to get x by itself. And as I look at my x's here, the x's disappear on both sides. They're gone, okay? But what I have left is 7 equals 17. We can't solve for x any longer because x's are gone, right? And so what would I say for my solution here? No solution, okay? Because these two are not equal to one another, we would say there is no solution. If we go back to the graph, what would happen here is that means both of these graphs have the same slope, okay? They are parallel to one another. They are not crossing. So we have two linear equations, but they will never cross. So that's where we would come up with a no solution. Okay, another one kind of along the same lines. And once again, these could be a little bit more involved than what I'm giving you here. But as I look at the two equations, what I notice is they're exactly the same equation, right? Negative 1/3 x, negative 1/3 x, positive 3, positive 3. And maybe you notice that, maybe you don't, but let's say I don't recognize that they're the exact same equation, and you just dive into solving this. I would add 1/3 x to both sides. Once again, my x's have disappeared. But the big difference here is the number that we have left over is exactly the same. It's 3 equals 3. That is a true statement. 3 does equal 3. So what would be our solution here? It's close to all real solutions, but not really, because it's not everything. Okay, it's a little bit different than that. What'd you say? So one real solution would be, okay, if I were to draw this line to kind of remind you of what this would look like, the two lines are exactly the same line. They're right on top of one another. They have the same slope, same y-intercept, everything about them is the same. Anybody remember what we call that solution? Infinitely many solutions. Okay, and I'm okay if you want to abbreviate that IMS. Okay, the reason we don't say all reals is because not everything works. There is multiple points on this line. This line is going to go on forever. All the points on that line, but not necessarily all real numbers. So it's a little bit different than all real numbers. But there is an infinite number of solutions because we have a lot of points that would make that true. Okay, so those are just two different scenarios, very similar but yet different as well, based on what happens when I solve it out. Okay, we're going to do a couple of story problems because you got a few on your assignment today. And so I'm going to do a couple from your textbook. Just because it's easier to read through a story problem than me write it up here. So we are on page 92, 93 actually, is where it starts. We're going to do 3 different kinds of story problems. I just kind of picked out some different ones where we can like set up an equation. And obviously what makes this one a little bit more difficult is they don't just come right out and give us the equation, okay? So they're going to give us some type of scenario. We have to write an equation that represents that scenario, and then we got to solve it. So there's a lot of different things that go into this. All right, number 35 is talking about borrowing some money. So if you borrow money from a bank or anything for whatever, car or house or whatever, then they're going to charge you interest. So you're going to end up paying more because you've borrowed that money. And so in this case, she is borrowing money at 5% simple interest. Simple interest is this formula right here. We call this the simple interest formula. If you've taken personal finance, you've probably seen and done some different types of interest formulas and borrowing money out of bank or whatever. So this is just a real basic interest scenario where P represents your principal. How much money did I invest? R is the interest rate that you're investing at, 5%, 6%, whatever. And T is how many years you have borrowed that money for. Okay? Most of the time, if you go borrow money for a car, they're going to say, we're going to give you a 5% loan for 3 years, whatever it is. Okay? And P is how much that car costs, right? And how much you're borrowing. Okay, in this situation, though, it's a little bit different. At the end of 1 year, she owed a total of $1,365 in principal and interest. How much did she borrow? Okay, so the total that she owes is $1,365. So we're actually going to come up with an equation here. Okay, this equation right here only tells me how much interest I'm paying, okay, total. That doesn't tell me how much I borrowed originally. So we're going to do the original principal plus how much interest I'm paying, and that tells me how much total I would have to pay. Before we start plugging some numbers in here, I'm going to try to make this a little bit easier on us. If we see two different variables that are common here, what could I do with those two variables?
Cancel them out.
Kind of cancel them out, okay? And if we had numbers in here, we could combine them, but here we're going to go kind of the opposite direction. Instead of canceling them out, we're going to factor that P out, okay? We're going to take a P out of the two expressions. Because they have a P in common, we're going to take that P out. Okay, and here's where it gets a little bit tricky, but it's going to be a whole lot easier to do it this way than another way, is I take a P out of P, that leaves me 1 right here. Okay, so we're factoring that P out. If I take a P out of PRT, that leaves me R and T. Okay, and to save you some time, so like on the one that you do today, this is going to be basically what your formula is going to look like, okay? So it'll be kind of the same idea. And so that's kind of why I'm walking this one through with you. You can kind of skip all those other steps and go right to this equation right here, okay? So we want to know how much have we paid in total. Well, they told us that. $1,365 is how much I owe after 1 year. We don't know P. That's what we're trying to find. The interest rate is 5%. Whenever you have a percentage, we always change it to a decimal. So 5% is really 0.05 times time, which is 1. And that one really doesn't matter. But if it was like 2 years, I would put a 2 here. 3 years, I would put a 3 here. So I'm putting that in there so you know that the years might change. In this case, it was 1 year, so that makes it a little bit easier. Hey, 0.05 times 1 is 0.05. 1 plus 0.05 is 1.05. Hey, before we do the math here, let's think about what our answer should be. As I solve this out and get my answer, what do we know about P? Is it going to be more or is it going to be less than 1365? Okay, so this is how much I have to pay the bank at the end of 1 year. Okay, or how much I owe the bank at the end of 1 year. The amount that I borrowed initially should be what? Less, right? Because we're going to borrow a certain amount, okay? That's where the banks are going to make their money. They're going to take that amount, they're going to charge you interest, and they're going to add that interest on top of what you borrowed, okay? So this number should be less than this number because this was my initial loan amount that I started with, okay? And I only tell you that because I want you to make sure your answer, like when you get there, doesn't make sense. So in this case, it should be smaller than what we have right there. So if I take 1365 and divide it by 1.05, what do we get? 1,300. Okay. So I borrowed $1,300 from the bank for my student loans. Okay. And after 1 year, if I were to pay the loan off, I would have to pay them the $1,300 plus the additional $65. And so that's where the banks make their money, right? They charge you interest, home loans, car loans, whatever type of loan you're going to do, student loans, all work basically the same way. Okay, questions on that one? It's a little bit different, right? We're kind of manipulating the equation to make it a little bit easier for us to solve. But the hardest part, without a doubt, is setting the equation up to get what we need. Okay, let's do another one. Let's do number 45. Okay, this one is, I kind of like this one. I try to pick out some real life type scenarios where you might see this at some point in your life. You might say, well, where am I ever going to need math or use math? Okay, these are both pretty good examples, right? Everybody's going to probably take out a loan at some point in their life. Everybody's going to probably get a job, and maybe you got different options, okay? So a salary is where you make this amount for working an annual contract, right? So as a teacher, I make a salary. This is how much I get paid. It doesn't matter if I work 40 hours in a week or 80 hours in a week, I get paid the same amount. My paycheck is the same. There is no overtime or anything like that. That's my salary, okay? A commission is when I work a job that's paid off of a percentage. And so usually what happens is, like, for instance, a car salesman or a realtor, you make a base pay. So a car salesman, I've never worked for a car dealership, so I don't know exactly how it works, but my guess is they get paid like a base pay just to show up for work, do everyday tasks that they normally have to do to get you there. But the more cars that they sell, the more money they make, right? And so they're pretty motivated to sell cars. That's why if you walk into a car dealership, sometimes they can feel a little bit pushy maybe, because if they get that car sold to you, then they're going to make more money that day. And so that's how a commission works, is you get a base pay plus a commission based off what your sales were. Okay, furniture, cars, sometimes clothing, a lot of different things that work off commission. Realtors is another really good one. Okay, so in this case, we want to know our monthly salary. So this is not a yearly salary, this is a monthly salary. Is $4,200 for this furniture company. Or you can choose the base salary and a 4% commission on the amount of furniture that you sell. So we want to know, when will these two be equal? Let's put salary over here, since that's the way it's listed out. And we're going to say that X is the amount of sales. Okay, and you could use S for sales if you want to. I'm just going to use X, pretty common variable. Okay, the salary is a one-time deal. I'm making $4,200. No more, no less. Okay, if I sell a ton of furniture, I still make $4,200. If I don't sell anything, I make $4,200. Okay, commission, you're going to make $3,600 for your base. But on top of that, they will give you a 4% commission. So you're making 4% of sales. X is the number of sales. Once again, because it's a percentage, make sure we change it to a decimal. If you don't change it to a decimal, your numbers are going to be way off. Hey, hard part is getting it set up. If I have to solve this one, is this one a hard one to solve? No, it's just a two-step equation, right? But the hardest part is to get it set up. So I'm going to subtract 3,600 from both sides. And then we're going to divide by 0.04. So 600 divided by 0.04. What would that give us? Anybody punching in? 15,000. Okay, so what do you guys think? Does it sound worth it? Like, I would need to sell $15,000 worth of furniture in a month to make more money. If I sold more than 15,000, this is going to be better, right? If I sold less than 15,000, this would be better. You think it would be hard or easy to sell furniture?
Hard.
Might be kind of hard, right? It all kinds of depends on where is the furniture store located at, what's the price of the furniture, right? If it's really expensive furniture, man, it might not take as many things to sell to get there. So there's a lot of different things that would go into that, okay? And maybe they usually make you make your choice like when you first show up, right? And then can I change it down the road? If I want to change it, that's kind of up to the company. Okay, one more. This one is on the next page, number 52. Okay, children are planting a rectangular vegetable garden with a perimeter of 39 meters. So I'm just going to draw a quick picture here of a rectangle and say the perimeter is 39 meters. Okay, how do we find the perimeter of a rectangle?
You add up the four sides.
Mm-hmm. Yep. And so the real basic formula here would be 2 times the length plus 2 times the width, because the two lengths are the same, the two widths are the same. So we got 2L plus 2W. Okay, before we start solving this and do some things, there's a second piece of information that they tell us is the length is twice the width. Right now, I can't solve for L or W because I have two variables. We want to get this to the point where I only have one variable in the problem. If I have two variables, it's going to be pretty difficult to solve. So what we're going to do here is try to put one variable in terms of the other. So they tell me that the length is twice the width. So the length is 2 times W. The perimeter is 39, so we're going to plug 39 in for P. Now, instead of using L, we're going to represent L with 2W, because L and 2W are the same thing. So we're going to put 2W in where the L is. And then the other piece stays the same. So now we have an equation that only has one variable in it, right? And now this will be much easier to solve. So that's the whole goal. Try to get it into an equation that's easier to solve. So this would be 4W plus 2W, which is 6W, and then we just divide by 6. So the width is 6.5 centimeters, and then to find the length, what would we have to do? Based on what we did here, we said the length is twice the width, So we just take 6.5 times 2. And those would be our dimensions. Okay, as I talked about at the beginning of the lesson, we could check it, right? If you're not sure, does this make sense? Does it work? Plug 6.5 and 13 in for your dimensions. 13 plus 6.5 plus 13 plus 6.5 should add up to be 39. Okay, and if it doesn't, then we've done something wrong. Okay, that's all we got. The directions today are pretty straightforward. It's just going to say solve. So on 5 through 30, you're just solving an equation. The last 3 are the story problems.